Hello friends, we continue looking at the junior secondary syllabus, and this time we are looking at square roots and cube roots. Okay, so we'll start with square roots. The symbol that we have for a square root is given here. So this symbol that we are seeing here is the symbol of what we call a square root. Well, this one which has a 3 here is the symbol for a cube root. Okay, so now what is this square root that we are talking about? What is this square root that we are talking about? Here are some examples of what a square root is. So for example, let's look at multiplying a number by itself. An example is 2. When you multiply 2 times 2, you get 4. And what this means is that 2 is the square root of 4. 2 is the square root of 4 because when you multiply 2 by itself, you get 4. And 4 is called the square of 2. Okay, 4 is the square of 2. And 2 is the square root of 4. So here is the way it's written using the symbol that we have showed above here. The square root of 4 is equal to 2. So you actually find a number that you can multiply by itself twice to get what you have under the square root here. And so here's another example. 5 times 5 gives 25. So in this small equation that we have, 5 is the square root. 5 is the square root because when you multiply 5 times 5, you get 25. And so it can be written like this. The square root of 25 is equal to 5. And so let's find some square roots here now. Okay, so the question says evaluate. So we are starting with the 400 here, finding the square root of 400. Okay, so finding the square root of 400, okay, let's put some signs there. Okay, evaluate the square root of 400 and the square root of 225. Okay, so here is how we find the square roots without using our machines or calculators. Okay, because the junior secondary we don't use calculators. So what you do is for the first one here, you draw a tree. I call it a tree. Put your 400 on this side, and then you look for the smallest number that can go into 400 here. The smallest number. Okay, so apart from 1, of course. The smallest number apart from 1 that can go into 400 without leaving any remainder. And usually there are very few numbers that you can try. When you find a question like this, you can try 2, you can try 3, you can try 5. And mostly we talk about prime numbers here. Okay, so 2 can go into this number here. So we are going to divide. 2 into 400, we are going to have 200 here. So we'll continue dividing by the smallest number that can go into all those numbers. So here is 200 here. The smallest number that can go into 200 without leaving any remainder is 2. Okay, of course, when we say the smallest, we're excluding 1 because 1 can go into anything. Okay, so 2 into 200, we have 100 here. And then another number, smaller number that can go into 100 is 2. And so we have 2 into 100 here, we have 50. And then again 2 into 50, we have 25. Okay, so 2 cannot go into 25 because it leaves a remainder. It can, but it leaves a remainder. So we want a number that can't leave a remainder. So in this case, the smallest number that can go into 25 without leaving a remainder is 5. So we'll divide 5 into 25 and we get 5. And then we are going to divide 5 again into 5 here, we get 1. So when we reach 1, it means we are done with our question. So we are going to get all these numbers that we were using to divide here. So we have 2 times 2 times 2. How many are there? 1, 2, 3, 4. Times 2 times 5 times 5. Okay, so the next step is to pair them. Okay, 2, 2. We pair them 2, 2. Okay, so preferably like terms. For example, 2 and 2 here will go together. 2 and 2 there, and then 5 and 5. And then from each bracket, you get one number. You get one number from each bracket. So from here, we are getting 2, then we put a times. From this bracket here, we are getting a 2. Put a times 2 there. So 1, 2 there, and another 2 there, and then 1, 5 from here. Okay, and then we multiply 2 times 2 is 4 times 5. We end up with 20. So 20 is the square root. 20 is the square root of 400. Okay, so 20 is the square root of 400, which can also be written, and we say, okay, the square root of 400 is 20. Okay, so that's what we have. So now let's go to the next question. The square root of 225. So we are going to draw our tree again, and then we'll put 225 here. Okay, so we look for the smallest number that can go into this number here, and we don't have to guess. We know that 5 can go into this number. Okay, any prime number that can go in there, you divide. So we know that 5 can go into 225 because this number ends with a 5. So we are going to put 5 here and divide. 5 into 22, we have 4. Remainder 2. 5 into 25 there, we have 5. Okay, so 5 again can go into 45, so we put a 5 there. 5 into 45, we have 9. Okay, so the smallest number that can go into 9 is 3. So 3 into 9 is 3. Again here, 3 can go into 3 once. And so we end there, and then we get these numbers that we have here. So for us to get our square root, we are going to multiply these numbers that we have this side. 5 times 5 times 3 times 3. And then we can pair them, 2, 2. Pairing them means you write them 2, 2 in brackets. And then you get one number from each bracket. So from here, we'll get a 5 times. From here, we'll get a 3. And therefore, the square root of 225 is 15. Is 15. The square root of 225 is 15. And now we can look at cube roots. Okay, so let us look at cube roots now. We are just going to put it there on top. So cube roots, we'll call it question 2. Evaluate. Okay. The cube root of 216, and then B, evaluate the cube root with a 3 there of 27. Okay, so for cube roots, we are actually looking for a number that you can multiply by itself 3 times. You multiply it by itself 3 times to give you the number that we have here. So we are going to solve it in the same way we did for square roots. So cube roots, we are going to draw here for the first one. We'll draw, and then we'll put our 216 there. Then we'll start dividing. The smallest number that can go into 216 is 2. Because the number ends with an even number, it means 2 can go in there. So 2 into 216 there, we have 108. And then again here, 2 can go into 108 because it ends with an 8. So 2 into 108, we have 54. And then again, 2 into 54, we have 27. Okay, so now we have 27. The smallest number that can go into 27 is 3. So 3 into 27, we have 9. And then 3 again into 9, we have 3 here. And then again, the last one, 3 into 3, we have 1 there. And so therefore, we can write this as a product. The 216, we can write it as a product of its prime factors. So we are going to have 2 times 2 times 2 times 3 times 3 times 3. Okay, so now when it comes to cube roots, unlike what we were doing for square roots we were pairing them. Because it's square, it means to the power 2. So for cube root, since we have a 3 here, we are going to be putting them in groups of 3. So this group here and this one here. And then we get one number from each group. So from here we'll get 1, which is 2. From here we are also going to get a 3. And then we'll multiply 2 times 3 and we'll get a 6 here. And so when we have a 6 like this, this is the cube root of 216. And then for part B, the cube root of 27, so we'll draw here, we'll put the 27 there. So the smallest number that can go into 27 is actually 3. So 3 into 27 is 9. Again, 3 into 9, you have 3. 3 again into 3, you have 1. And so as a product, 27 as a product of its prime factors, we have 3 times 3 times 3. Okay, and so since there's only one group, we just get one number from there. And therefore, the cube root is 3 for 27.